Hello, everyone. I'm Dr. Darsh Shah.
And I'm Dr. Altamash Raja.
And welcome to Medicine Redefined,
a podcast where we will explore the often overlooked but necessary components of health, what we consider to be the fundamentals.
We will investigate topics and practices that can give you and your patients the best chance to optimize a healthy lifestyle. It's time to move the needle forward and put the health back in healthcare. Before we get into the show, here's a quick message from Physician Financial Services, a business widely recognized in the physician community for disability insurance. Lawrence B. Keller, CFP, has been in the insurance and financial services industry since 1990. Unlike medicine, which has a standardized path that physicians must take to gain the education, training, and experience requirements necessary to obtain board certification, the insurance and financial services industry does not. While he might not be a doctor's first phone call regarding their insurance needs, he is often their last. Find Larry at drpodcastnetwork.com/Larry Keller or at the link in the description of this show. All right. Hello, everyone. Welcome back to another episode of Medicine Redefined. In this episode, we get nerdy with Dr. Patrick Finan, who is an associate professor of psychiatry and behavioral sciences at Johns Hopkins University. His research includes the understanding of the relationship between sleep and pain. And we really try to break down each category on its own first, pain, and then we go into sleep. And then Dr. Finan does an incredible job tying the two together. This is really a fascinating topic where the research has only touched the tip of the iceberg. All right, let's flood your brain with some knowledge.
All right, Patrick, welcome to the show, man.
Hey, thanks. Thanks for having me.
You know, Patrick, it's funny. I think that, we met, I guess, sometime around 18 months ago. And the way I came to learn about your work is basically one of those little recruitment flyer things outside of the medical school bathroom where it's like grab a tab and learn about this study. And, we met up in your lab and I kind of got to learn a little bit about your work and two topics that we're going to discuss today that we have what I think is extremely poor understanding when it comes to medicine, and especially in medical school, we don't learn a lot about. So I'm definitely excited. And you were kind enough to kind of get me onto this project, but unfortunately then the world stopped and we haven't really made much progress on that. So I've been stoked about this conversation and I'm so excited to learn, man. But for our listeners who might not know who you are and don't know much about your work, why don't you tell us a little bit about your journey, how you got to where you are now and what it is that you do?
Sure. I'm going to have to compliment my research team on the recruitment tactics. If they're able to snag you from one of those pull tabs, that's good work. We need to do more of that. Exactly. And yeah, we've been shut down, like everybody else, but we're getting back up. So yeah, I'm a associate professor in the Department of Psychiatry. And hang on one second. I'm sorry, I'm getting some feedback here. Okay. I'm an associate professor in the Department of Psychiatry at Johns Hopkins, and my work is really broadly focused on chronic pain mechanisms that contribute to adaptation to chronic pain, vulnerability to chronic pain, and resilience over time. So we try to approach pain from a kind of I would say a holistic angle, a whole person angle. And that's kind of how I got into sleep, through being really interested in the mechanisms. And what we found out over the years is that when we look at how people with chronic pain sleep on a day-to-day basis, it kind of unlocks a lot of insights into their kind of day-to-day function.
It's super fascinating. So, I mean, this conversation is going to be about pain and sleep, and something that a lot of people, I think, don't really connect together. But let's for a second separate the two, if we can. Talking about pain, it's obviously a very complex process that I think a lot of humans probably don't understand. I mean, when I think of pain early on, I'm thinking something that I'm touching, and ouch, maybe a sensory nerve signals my brain, and then there's some feedback loop. So can you kind of just break down what is pain? Are there different types of pain? How should we think about it?
Yeah, good question. So definitely there are different types of pain. I think the best way to kind of break it down is the classic conceptualization of pain from the early Melzack studies. So if we think of pain as having three core components, there's a sensory discriminative component, and that is the aspect of pain in which we are able to kind of determine, is this stimulus painful or is it just warm? Is it painful or is it cold? So that's the sensory discriminative component. There's a cognitive evaluative component, and that's the piece of pain where we kind of make decisions around what to do when we experience pain. And so that, of course, interacts with the sensory discriminative component, but has its own kind of set of decision-making parameters and different parts of the brain that are responsible for driving those types of thoughts. And then finally, there's the affective motivational component. Again, interrelated with the other two, but that part of pain typically is characterized by the kind of emotional state that one is in when you experience a painful stimulus. And those emotional states are going to drive decisions. They're going to stamp in memories. And so it's really kind of all three of those components are interlocked. And it's important to be thinking about all of them.
Yeah, that's pretty fascinating. It's definitely more in depth than what we have learned about in pain. And I think that for those sometimes people, misrepresent like what we do. We're physical medicine rehab. Sometimes people will say pain medicine rehab just by the sheer volume of how many people we see. And pain's such a universal thing, right? Every single person who's listening to this has experienced pain to some degree. They are definitely not thinking it from the lens that you just described it. But touching on to your last point about the emotional component, this past year has been, I guess we're up about in a year of lockdown at this point. And, it's been high anxiety. The emotions have been kind of up and down for various different reasons, right? Are you familiar with, is there any literature coming out now that's talking about the prevalence has gone up because of that, because of the changes in emotion?
That's a good question. I can't say that I've read anything that's kind of linked it specifically to that. I think we can expect that to happen. We are seeing that rates of pain are increasing. We know, for example, that COVID-19 is related to, just like a number of viruses are related to increases in pain sensitivity. The case of the long COVID, which is kind of increasing in how much the public is becoming aware of it, is really starting to look like a lot of the chronic pain syndromes that we see. If you take a look at things like Gulf War syndrome, these types of chronic pain syndromes that come about through sort of mysterious, potentially viral sources and also traumatic sources. Everything's kind of aligning in that way. So we're seeing those types of pain increase. And of course, then you can extrapolate from the mental health data that's coming out, where we're definitely seeing dramatic rise in depression. That we would then expect to see increases in chronic pain result from that, because that literature is really well founded. We know that when we see increases in depression, we're going to also see increases in chronic pain. Sort of lag right there.
So yeah, Patrick, I think that makes a tremendous amount of sense. There's been a lot of talk lately, and from the literature that I've been looking at, we're familiar with, norepinephrine and serotonin and their integral role that they play in both mental health and obviously chronic pain, and how, they're correlated with each other. But the dopamine signaling pathway is somewhat of a novel idea. So what are your thoughts on this? And, what does the literature tell us about, its role in pain specifically?
Sure. So we know a few things about dopamine. We know dopamine produces endogenous analgesia. It's recruited in the face of various nociceptive insults. We've seen this in preclinical literature, And then in the early 2000s, there started to be a series of studies that started to demonstrate this in humans. In a few studies with patients with fibromyalgia, we've seen differences between cases and controls in dopamine binding using PET methodology. We've seen differences in dopamine metabolites in the CSF of patients with fibromyalgia compared to controls. And then in addition, we've seen a few candidate gene studies, or sort of early candidate gene studies, suggesting that there were differences in rates of the expression of the COMT gene, the catechol-methyltransferase gene, which regulates dopamine signaling. So that kind of formed the basis of a lot of interest of pain researchers to try to figure out what might be going on with dopamine. And for me and some of my colleagues, we've kind of taken that to suggest a couple of things. One, we've hypothesized that if there are dopaminergic differences in patients with chronic pain, then we would expect to observe behavioral and emotional differences that would reflect that kind of alteration in dopaminergic signaling. What types of behavioral and emotional differences would we expect? One, we would expect there to be differences in the ways in which patients with chronic pain experience rewarding activities. We would expect there to be differences in the degree to which patients with chronic pain are able to experience positive emotions, and possibly the degree to which positive emotions are able to sort of serve their function in patients with chronic pain, either by being sort of analgesic agents. So the expression of positive emotions has been robustly demonstrated in the literature to be associated with analgesia. And so we would expect there to be differences there. And possibly we might expect there to be differences in the way in which patients with chronic pain experience drugs of abuse. And some of these questions have started to become answered. We've seen in the last several years a number of studies showing that patients with chronic pain indeed seem to evidence reward processing deficits. We've seen this using experimental tasks. And in my lab, we've observed not only different deficits in reward processing to natural rewards, rewards like money, but we've also seen differences in the day-to-day experience of positive emotions. And that's kind of where our focus is in trying to really narrow in on how can we develop treatments that kind of stem from this possible reward deficit that we're seeing in patients with chronic pain.
Yeah, I mean, that's truly fascinating stuff. I think I probably should have started with this. I think it's worth taking a step back and just explaining exactly what dopamine is. I mean, for those who don't know, we have a bunch of neurotransmitters, right? Some of the common ones that people probably are familiar with is serotonin. It's the one that, makes you feel good. We have GABA, we have acetylcholine, norepinephrine, and which is kind of like the adrenaline, your body's endogenous opioids, which you talked about. So dopamine is the one that's implicated in that reward pathway. You've talked about that already, but it's the one that kind of has the addictive properties. Exercise will increase your dopamine levels. That's kind of part of the reason why you feel good afterwards. Food has a tremendous thing. When you eat that pizza, you get this massive dopamine response, and of course, drugs like cocaine and stuff. So I think that probably people can probably have a better understanding of what that is. But I want to go back to this point about the COMT gene that you had talked about. Say a little bit more about that, because one of the things that Darsh and I are fascinated about is this idea of precision medicine. And I think that more and more people are starting to learn, go through their 23andMe or Ancestry DNA and learn about these SNPs, right? The single nucleotide polymorphisms. And we know that something like the ApoE is implicated with Alzheimer's and cardiovascular disease. Previously, Dr. Arndt was here. He talked about the ACT1 gene, which is more for like power athletes. And the science isn't quite there yet. And I imagine with COMT, it's probably similar, but it sounds like it's exciting stuff, but what does it tell you? What does it tell us in science in terms of, how different people might perceive pain, because that's an important thing.
Yeah. Well, so yeah, I think you have it right. I think the COMT studies largely came about in the early days when folks started to realize that they could measure these things called SNPs, single nucleotide polymorphisms, and get data sets that allow them to use this as like an individual difference factor. So a SNP can tell us a little bit about something. It can tell us, for example, whether a part of a gene is likely to have a function at a molecular level. But then there are so many kind of intervening variables that can kind of muck that up. And the early SNP studies, COMT included, were largely run in samples that were far too small to really have the power to be able to detect kind of meaningful differences. And my dissertation was a good example of that. So I did a dissertation looking at COMT Val158 MET SNP differences in patients with fibromyalgia. And we were looking at the degree to which having a quote unquote risk allele on the Val158 MET SNP was associated with differences in positive emotional functioning from day to day. So you can that genetic work is important because it generated a lot of ideas, and there very well may be a realistic signal in those data. But with respect to the COMT gene and pain, I think the field has kind of largely moved on from the idea that we can reliably use an allele that someone may or may not have to accurately predict whether they're going to have pain, for example, or whether they're going to develop a mood disorder in the course of their illness. The data just never materialized to kind of achieve that hope. I think large scale, genome-wide studies have since taken over, and that work's ongoing. And so something, at a massive scale may one day demonstrate, some kind of predictive utility there. For me, that work really was just pivotal in trying to think through a couple of things. One, it helped me think through what measuring something like the COMT gene and the Val158 MET SNP couldn't do. And and what it couldn't do is tell me whether there was actual, for example, dopaminergic changes going on a day-to-day basis. I could presume that somebody might be predisposed to have an attenuated dopaminergic response to a physiological insult, but that's always just going to be an assumption, right? You're assuming that because of the kind of presumed molecular action that might be the case. But what you can do is then start to generate hypotheses from those signals and take a look with methods that are maybe more reliable, more robust, things that you can more accurately measure in kind of smaller samples that are feasibly accomplished in human subjects research. And that's kind of what we've tried to do. So we're doing studies where we're really trying to understand reward processes broadly in patients with chronic pain. And that's frankly how I got into doing sleep research. We talked about sleep earlier on. And what we realized about a decade ago is that a lot of the reward-related mechanisms that we were interested in chronic pain appeared to be modulated by sleep. And there was this kind of bubbling literature demonstrating that sleep was robustly associated with pain. And so one of our kind of core hypotheses that we've been tracking down in a number of different ways over the years is that this association between sleep and pain may be driven to some extent by deficits in reward processing, deficits perhaps in dopaminergic functioning, deficits building up from dopamine, deficits in corticostriatal function that might be important to try to track down. So that's what we've been up to.
Yeah, that's a pretty awesome explanation. Do you know if that COMT gene is like, with 23andMe or these like online DNA thing, that self DNA kits that people can get, if they give you that information, that whether you have that gene or not? Because I hadn't heard of that until like I read your work.
That's a good question. I don't know if that's like available in commercial assays. It's a super common.
Is it? Okay.
Gene. Yeah. It's one of those, if you look up Val158 MET SNP, you'll see, just about every complex behavioral trait associated with it in one way or another.
Okay, I see. Yeah, no, I got to go back and look at some of the raw data and stuff to see if that offers it, because, my fear is, so what you were talking about before, this is the classic thing, genotypic versus phenotypic expression. And right. And this is why the science of epigenetics is so fascinating, is because obviously we know so many things after the genes that you've been encoded with, like your environment and, the way that your behavior and stuff will influence, and pain, as complex as it is, as you've described it, is affected more so than almost anything else. And I know that there's literature out there, like when we're talking about doing procedures on people, by simply telling them, hey, that when you're giving them anesthetic like lidocaine, by simply telling the patient that this is going to pinch or this is going to burn, the perception is that procedure is much more uncomfortable, rather if you as opposed to if you didn't tell. So, if somebody was to see this data for themselves, and you touched on how they might be likely to develop in the future, it just seems like a scary proposition to kind of give that data, but yeah, I don't know if it's even available or not. But I want to go back to, you had mentioned a couple of times that in terms of this specific genes and then the dopamine signaling pathway, you were looking in fibromyalgia, right? That's part of what your research was on. Do you know if other, pain states like RA or inflammatory conditions like that, or just like, mechanical pain, if they have a similar mechanism, or is the dopamine signaling pathway implicated in that, or is it primarily just fibromyalgia that you guys have looked at?
No, I mean, fibromyalgia was that was like some of the early literature. There have been reward processing deficits, and I believe also dopaminergic deficits, although I'd have to go back and check my sources. But certainly broadly reward processing deficits observed in a variety of chronic pain conditions. I think the reason folks started with FM is because the constellation of symptoms in FM really kind of dovetailed nicely with the proposed theoretical mechanism by which dopamine may alter function, right? So with fibromyalgia, the constellation that you very often see is sleep deficits, the experience of depression and anxiety, and then widespread pain, right? It's like those three, and you rarely see just kind of pain alone. And so I think dopamine is a neurotransmitter that serves a variety of other neurotransmitters, right? It's not an endpoint; it's more like a messenger in between. And so you would expect there to be kind of a wide net cast. And so I think that's why the early studies focused on fibromyalgia.
Gotcha. Patrick, as a doctor on the wards, I'm seeing mental health issues every single day, right? From bipolar to schizophrenia to depression, fibromyalgia. And I'm very interested in kind of this chicken or egg situation. Is there any research that shows that it's the pain that's causing these mental health issues, or is it usually the mental health and then the pain's coming along with it for the ride? Is there any research that kind of shows one or the other?
Yeah, there's no definitive research that kind of points to one direction. There's lots of research showing that each of those conditions can lead to the other, and that they're highly comorbid with one another. And so there is a sort of when somebody develops chronic pain, I think it's a reasonable assumption that if there's not a history of mood disorder on board, that in developing a pain treatment plan, it would be a good idea to kind of keep an antenna out for that type of problem to develop over time, to think about the possibility that repeatedly dealing with pain on a day-to-day basis, the loss of function, the loss of social contacts that often occurs, really is like a breeding ground for the development of a mood disorder. And having that kind of foresight early on in a pain treatment plan, I think would really go a long way to helping patients ward off those types of.
So I wanted to follow up on this. So I read a book called The Anatomy of Hope by Jerome Grootman, and he's a famous doctor writer. So he talks about how he dealt with back pain, and he ends up going to like Beth Israel in Boston, and he meets this famous doctor. I can't remember the name, but essentially the doctor's telling him, hey, a lot of your pain is just mental. It's these patterns that you're forming, the trauma, tightening your back, all these things. So from your standpoint, is it worth us providers going to the medication first to treat the pain and hopefully alleviating some of those symptoms? Or would you rather take more of a mental health approach to these, neural patterns that patients might be forming with their pain?
So, it's tricky. I think the first thing, we can take a step back, and there is an interesting kind of discourse in the research world and in the clinical world around this concept that pain is quote unquote mental, right? So to phrase it in that way can be really stigmatizing for patients. And patients will almost uniformly recoil at that kind of phrasing, right? The idea that it's all in my head. That's like the one that you hear the most, right? And so I'm a pain psychologist, and as a pain psychologist, the first thing that I have always done working with chronic pain patients is kind of address the elephant in the room right away. And that elephant in the room to me is all right, let's talk a little bit about the neuroscience of pain. We know that pain is processed in the brain, and that is just, when you experience pain, it's because your brain's working in a way to communicate signals that let you know that you're in pain. So that's a good thing. So we're going to accept right now that pain is in your head, but we're going to refute the notion that it's all in your head, quote unquote, right? And we're going to sort of just radically disavow this idea that any patient with pain is kind of making up their symptoms or experiencing their symptoms as some kind of secondary reaction to an emotional trauma. So I think that is a really important place to start, to kind of let patients know, all right, your brain, your emotions, your thoughts are all critical to how you experience pain and maybe critical to your recovery from pain. But that doesn't mean that that any of us in the room think that you're making these up or you're looking for something else other than just to try to feel better. So that's kind of like an important issue that as a pain psychologist, I've found myself having to deal with right away, because patients will often be really on guard and in many cases resistant to engaging in the type of pain self-management practices that require an acceptance of the fact that the way we think might influence, for better or worse, the degree of pain that we're experiencing, that our emotional reaction to experiencing a spike in pain may facilitate further pain. And if we can work on control, we may not be able to control the degree of pain that we're experiencing depending on what's going on, right? We might not be able to control that, but we might have a good chance of controlling the types of thoughts that pop up associated with those pain insults. We might have a good chance of controlling the types of emotions that are associated with it, and that can kind of sort of bring the power back to the patient and help them on their journey.
Yeah, you know what's interesting is I don't know exactly when we started. I think that at least at our institution and a lot of the smarter physicians that I've learned from who are doing pain management, they started to appreciate the biopsychosocial model a lot more, right? We know that as a staple of treatment for somebody who's in chronic pain, CBT is part of it. It's a multidisciplinary approach, even though if there's a a biomechanical issue that's wrong, you're going to try to address that, but that's not going to cause 100% resolution. So they have to, try to, tackle it from multiple different approaches. And I think that's something that's really important to understand. And it also falls on us as providers to be very selective with our words, because at the end of the day, as I alluded to earlier, they're powerful, and just by telling somebody, hey, that this is going to hurt, like that can cause it to be a much more unpleasant experience. And so somebody who's already hypersensitive and they're in this hypersensitive state, it's going to make it that much worse. Darsh, here's an interesting book for you. I think that there's this PM&R doctor named John Sarno. He wrote this book called Healing Back Pain. Essentially, he talks about this concept of tension myositis. I'm not sure if that's something you guys have heard, but essentially it's a very psychosomatic approach to, whether it's hamstring strains or back pain is kind of the most common thing that he talks about. But I want to pivot a little bit though, Patrick, and ask about just in states such as, chronic regional pain syndrome or just anything, even fibromyalgia or something like that, where you have this chronicity, for longer and longer time, but then people have, hyperalgesia or even allodynia. And for those who don't know, basically allodynia is when somebody, it's like a normal stimulus that shouldn't be uncomfortable causes extreme pain. So that would be if I was to kind of touch your arm, Darsh, you would have a tremendous amount of pain. So it should be non-painful stimuli that evokes a painful potential, right? Essentially. So is there something unique when it comes to the mechanism, Patrick, about those specific instances, like those conditions?
So you're asking about CRPS, or are you asking about allodynia in general?
I think just hypersensitivity, because a lot of times with CRPS you'll get allodynia, at least from what I've seen. But if you think they're different, I'd be happy to hear the differences between them.
No, so we have some nice tools to be able to differentiate those responses in the lab. So we have experimental tools, part of a suite of things we call quantitative sensory testing, that we can use to be able to tell whether there is a greater degree of, for example, hyperalgesia, sort of an exacerbation of pain to an otherwise painful stimulus, or allodynia, as you described, pain when the stimulus is not painful. I think whether a treatment plan would differ depending on that, whether there's, for example, hyperalgesia or allodynia on board, I think that's going to vary on a case-to-case basis. From the biopsychosocial standpoint, we're going to take that information in. Each person's experience is going to determine how we're going to approach it across all levels in terms of what types of providers are you engaging with, right? You want to make sure that if a multidisciplinary care plan is necessary, that you bring somebody on board. So if there's, for example, a clear kind of allodynic process going on, I might want to get a neurologist to check something out. Whereas if it's kind of purely musculoskeletal, there's not a sort of clear neuropathic pain, well then that might change course, and maybe we'll be thinking more about physical therapy, or maybe we'll be thinking about all of these things. So we kind of take it on a case by case basis. I don't think there's like a clear rule of thumb that will drive a comprehensive multidisciplinary pain treatment plan, whether there's allodynia or hyperalgesia on board.
Patrick, I'm extremely offended. You have two physiatrists sitting in front of you, but you get a neurologist a shout out. What's that about, man?
Yeah, you're right. That was messed up.
Come on, man.
It's a latent problem.
Love it. So Patrick, you mentioned earlier that your research now, you're starting to look into sleep a little bit more and its association with pain. So I think this is just going to be a great segue now. As I got my blue blockers on, I feel my melatonin surging in my body. Can you take us through sleep physiology, just kind of the stages and the purpose of them? I think most people know about REM and maybe non-REM, but that's about it, I'm thinking.
Sure. So those are blue blockers. I thought they were just cool looking glasses. I I'm impressed. You're anticipating the need to get to sleep after this at some point. Yeah. So you're asking just in general about kind of sleep physiology,
Yeah.
basic overview. Yeah. So all right, we tend to think about sleep in my world in kind of two broad dimensions, and there are other sleep folks who are going to get much more into the weeds on this than I will, but I'm going to give you the two kind of key areas. We think about sleep architecture, and so that's the sleep staging, and I'll walk you through that briefly. And then we think about sleep continuity, and so I'll start with sleep continuity. In sleep continuity measures, what we're looking at is the quantity of sleep that somebody's getting, their total sleep time. We're looking at how long it takes them to fall asleep. We call that the sleep onset latency. We look at how many minutes they're awake in the middle of the night. We call that wake after sleep onset, or WASO. We look at the total number of awakenings that they might have throughout a night. We look at their time of final awakening. And then behaviorally, we also look at the time that they got out of bed, because in some cases, the final awakening might happen at 5 a.m. and they don't get out of bed until 7 or 8 a.m. And so that falls under the kind of broad rubric of sleep continuity, which the gold standard assessments are a sleep diary. So you just ask a patient to tell you the timing, the number of minutes, and the times in which they fell asleep, and times in which they woke up. That used to be done with paper and pencil. Now there's a million apps that make it really easy for patients to input that type of data. And then, of course, most people are familiar with all of the wearables that are out there that objectively track all of these things, with typically with actigraphy, although there are other kind of ways to do this now. Actigraphy is basically looking at activity counts. So the most common way to do it is somebody wears an actigraph on their wrist, and when they fall asleep, typically there are very few movements. You got one on now, yes, like a Fitbit, or really, any of those wearable technologies have some kind of triaxial accelerometer baked in there. So we can get all of those measurements really easily now, and that gives us a good sense of how much somebody is sleeping. The sleep architecture component is looking at the stages of sleep. So, we have the stages of sleep progress from sort of very light sleep to progressively deeper sleep. So the lightest sleep would be stage N1, and then you cycle into stage N2 sleep. We spend most of the night typically in stage N2, and then we spend about 20% of the night in stage N3, which is also known as slow wave sleep, or the kind of deep sleep. And so there's a lot of interest in the degree to which one is able to achieve slow wave sleep. There are certain disorders and certain drugs that can make it very difficult to achieve slow waves, and folks who have that phenomenon often report feeling that their sleep was very unrefreshing. So they may actually sleep a full night. They might get, if you look at their sleep continuity indices, you might see what otherwise looks like normal sleep. But if there's, for example, no slow wave sleep, that might contribute to the kind of experience of feeling unrefreshed in the morning. And then finally, we have REM sleep. So the first three, stage N1, N2, N3, are all NREM sleep stages. And then finally, we have REM sleep. REM sleep also tends to happen about 25% of the night, give or take. The predominance of REM is in the latter stages, the latter parts of the night. So you typically have more REM in the last kind of 4 hours of sleep, and more slow wave sleep in the earlier parts of the night.
Patrick, that's interesting. Yeah. So I was familiar with alcohol and its role at just kind of curtailing REM sleep. I mean, I've read about that quite a bit, and Matthew Walker speaks about that, and he's I think most people probably know him from his book Why We Sleep. But what specific drugs were you alluding to when you're talking about the N3 or slow wave sleep that you talked about? What kind of common medications might,
Opioids. Opioids is the number one that comes to mind. So opioids typically just knock out N3, slow wave sleep. Some people, it's not uniform, but it's a very common phenomenon, and you can observe it really clearly in people with opioid use disorder who are on agonist maintenance medications. So you see, and we've published on this as well, really very little stage N3 sleep in folks with opioid use disorder.
Wow. Well, this is the perfect segue because, like I said, what kind of attracted me to your work is sleep is, if you've talked to me over the last 2 years, it's my favorite thing to do. I'm absolutely fascinated by it. And so, the way that I wanted to look at, basically pain was, or sleep was as an antidote for pain, essentially. And that's kind of what you've been working on for the last couple of years. So it's crazy to me that when we're trying to address pain with opioids and we know that sleep can have quite an impact when it comes to, pain perception and sensitivity and how people, just the whole experience of pain. So talk a little bit about like what you've learned or what you're working on currently in terms of the relationship between sleep and pain. Again, is it a bidirectional thing? Is it more of a causal, effect? How does sleep, tie into just pain and the experience of pain?
Yeah. So, like the question about mood disorders and pain, we see a reciprocal association with sleep and pain. So it's not necessarily if we're trying to get to a chicken or the egg answer. There's not one that necessarily happens before the other. However, in the last decade, we've really seen a number of studies show. Now to the point where I'm pretty convinced that this is a real phenomenon, that the bulk of the variance, the majority of the variance in the sleep-pain relationship is accounted for by the sleep into pain directional pathway, more so than pain into sleep problems. And that might not be intuitive, particularly folks who have chronic pain and will report very clearly, I couldn't sleep because I was in so much pain. It was and so you, of course, are going to have lots of examples of people who will say my pain inhibited my ability to sleep. And that's absolutely a phenomenon. But if we look at the literature on the whole, including the experimental literature, the clinical trials literature, the longitudinal and micro-longitudinal, the kind of like intensive day-to-day studies that are out there that are able to kind of disentangle the direction of this relationship, we tend to see that sleep problems beget pain problems more often than the other direction.
Yeah, no, Patrick, I'm sorry to interrupt there, but I can tell you, absolute certainty that that's the case. In fact, I mean, part of the way that we make decisions and what type of interventions we're going to do for pain management is, the question we ask, well, how do you sleep? And I think that even us as physicians, we're only starting to understand that but the understanding is, again, it's going back to that biomechanical model. You're like, okay, you have this pathology, whether it's a disc herniation or a fracture somewhere, and that's why you can't get comfortable in bed because of pain, and that's why you're not sleeping. But what you're talking about, hey, it's the opposite. So yeah, I'm sorry to interrupt there. I just wanted to kind of.
Yeah. No, it's good to see that there's some concordance with what you're seeing on in the clinic. And yeah, so that has formed the basis of a lot of research that has attempted to treat sleep as a means of improving pain. And so what I can tell you about that work is that it's very unfinished, and I find this kind of fascinating, right? So we can look in the experimental and the longitudinal observational literature and see this directional path that we just talked about. Sleep problems leading to increases both in acute pain sensitivity and into the development of chronic pain over time. That data is really clear. So the presumption then would be, well, if we treat sleep effectively, are we are we then going to see a downstream? We would assume that we would see a downstream benefit in pain. And interestingly, there have been, I don't know, 7, 8, maybe a few more clinical trials of various cognitive and behavioral approaches to treating sleep, and in particular insomnia, in patients with comorbid chronic pain and insomnia. And these trials have attempted to employ CBT, cognitive behavioral therapy for insomnia, in these samples. And they've shown almost uniformly that CBT for insomnia is very effective in treating insomnia in patients with these comorbid disorders. It is, for reasons that we're still working out and I think are kind of fascinating and point to some potentially interesting mechanistic discussions, it's much less effective in solving the pain problem, right? So we're learning from those studies that even though we know that there's a strong link, the resolution of sleep-related pain problems is not happening just by improving sleep. And so that's led us to really narrow in on, well, what are these kind of intermediate mechanisms that are taking place? And should we be taking a kind of more complex view of the scenario? I'm focused on affective mechanisms, reward-related mechanisms. And I think if we start to, Darsh, getting into your point earlier about precision medicine, taking more of a precision medicine approach to this sleep pain problem, we're going to, I think, start to find kind of focused and targeted therapies that can help folks with one constellation of symptoms that may not help another set of folks, and we can tweak our interventions and tailor them for this other set of folks who have another constellation of problems. Because we can only presume that pain and even the sleep pain dynamic isn't happening in a vacuum, right? That there are these other kind of symptom complexes that are taking place that may be maintained if we don't focus on them as well.
Yeah. I mean, that's really awesome. Patrick, do you know, in terms of, you said basically that the traffic is flowing a little bit heavier towards one direction. And if that literature was able to tease out, whether it's new incident of pain, like for instance, does it decrease the threshold for somebody to experience pain with another incident that they might experience the next day? Or is it more that it's increasing the intensity of a current pain condition?
We've seen both. So there are longitudinal epidemiological studies. I'm thinking of a couple that I believe came out of Norway over the years that have shown that insomnia symptoms at baseline predict new incidents of chronic pain down the line. And then there are studies in patients with chronic pain where we look from day to day at their at sort of variation in their sleep continuity, for example, the degree to which they are achieving total sleep time consistent with their average, or sort of maintaining sleep continuity throughout the night, sort of not having a whole lot of wake after sleep onset. And we can see that nightly elevations in things like wake after sleep onset promote increases in pain the next day in people who already have kind of chronic pain on board.
And is there a difference between whether it's sleep onset insomnia versus sleep maintenance insomnia, or is it all categorized under one?
No, there are differences, and those are two kind of categories, right? So you've tapped into two categories of insomnia, and I can't say that the literature is sort of resolved with respect to whether one versus the other is more important for chronic pain, for example. We've been particularly focused on sleep maintenance and insomnia, and measuring kind of aspects of sleep maintenance insomnia in experimental paradigms. And so that's been a particular focus of ours. But I think the literature is probably undecided about one versus the other.
Yeah. And I think it's worth mentioning, though, what we know for certain is that sleep has a profound effect on performance when it comes to performance in sports. And obviously the literature is pretty clear that when it comes to injuries, you are much more susceptible to injury, looking at not only the athletic population, but even just the lay population. So I wonder if they controlled for that to see if there were any new injuries, or if that kind of included that. I'm not sure.
That's a good question. I can't say the work that I'm familiar with actually doesn't get into sort of injury too much, but that's a fascinating angle. What have you seen in that regard?
Well, I mean, we know that obviously hamstring injuries are extremely prevalent when it comes to just any type of field sport, any type of sprinting sports. And I could be misquoting here, but there was some work done from this lab out in Stanford. They're talking about how, sleep impairs or the risk of hamstring injuries kind of, I forget how much the increase is, but it's markedly increased after just in sleep deprived individuals. And these were subjective scores, self-reported, kind of what you had talked about, the diary and stuff. I don't know. I don't remember exactly how they tracked it. And obviously a lot of the work is being done in NBA players because they travel from, whether it's East Coast or West Coast, and they're kind of getting late to the hotel, and then they have a game the next day. So they're in sleep deprived situations. And so there's a lot being discussed in the professional realm on that regard. So I mean, it's truly fascinating stuff. And we're just starting to, I do love the fact that we're starting to appreciate it more and talk about it more. But I mean, there's just so much to learn, and so little we know.
Completely. Yeah. I wonder what's going on in those, professional sports teams. I've seen that. I think many of them do have kind of sleep specialists on board now. But I would love to see kind of what the protocols are. I'm not too are they publishing that type of thing in the academic literature?
I haven't seen anything, but have you?
Some. Yeah, I mean, some of it. I think I don't know about the professional level, but I know at the collegiate level it's being published. I think it's a little bit easier to get access to that data, obviously, for university athletes. Mm-hmm. I don't know too much about the professional, but I wouldn't be surprised, at least. And I feel like Europe is ahead of us when it comes to this type of stuff. So I wouldn't be surprised if we had some good data on like soccer athletes.
I think maybe like a year or two with the NBA, because I know that's a huge issue in the NBA now that they're really trying to track down. I think some of the stats they were saying is like NBA players might sleep at like 12 a.m. just given jet lag and things, and then wake up around 5 just to get a workout in. And they've really seen the injury rate go up because of that, especially with the amount of games that they're playing. So I wouldn't be surprised if we start seeing that data in a year or two.
Yeah.
So I also wanted to ask you, Patrick, about the opposite of insomnia. Is there anything that shows us that you can also have too much pain if you're sleeping too much, or is it really only just kind of that insomnia state?
That's a good question. And I'm less familiar with the sort of hyper somnolence literature. I know there is one out there. It is I could say it's not it's not a sort of primary focus of the sleep and pain literature. Largely, the vast majority of that work really focuses on the loss of sleep and various ways in which you can lose sleep. But the hypersomnolence, I think, tends to focus on affective problems that emerge in the context of sleeping too much, and I believe there are some data with pain, but I'm not familiar enough with them to be able to talk about them.
Yeah, I mean, I wouldn't be surprised if there was, to be honest with you. I know that I remember that, again, there was a paper I was looking at in I think it was a journal of in cardiology, talking about how less than 6 hours of sleep, there was significantly higher mortality associated with that. And then the same was true for sleeping more than 10 hours. And I remember, Matthew Walker gave a great explanation for this, basically talking about how individuals who spend more time in bed, it was basically that they might be fighting a disease process, and your body is, he describes as the Swiss Army knife that you have to fight any disease essentially is to sleep. And in these individuals, basically your body is telling you to fight this disease process, you should sleep more, but unfortunately sleep failed and then they died. So it's kind of hard to tease out. And I wouldn't be surprised in individuals who are spending more time in bed because they're in this anhedonic state, or because they're depressed and whatnot. And again, going back to the idea of, hey, there's a high correlation for just your experience of pain when it comes to that type of stuff. Yeah. But yeah, I mean, that's kind of what makes this super awesome.
Yeah. I think that's certainly an interesting angle, and I think the thing to tease apart, and some folks may be doing this. I'm not familiar, but the thing to tease apart would be to what extent is the hypersomnolence a sort of secondary aspect of an anhedonic process that's going on versus a physiological kind of drive to sleep 10 or more hours that would then be related to subsequent pain. I think that would be the thing to try to figure out.
Yeah, absolutely. So how do you, like, when you get somebody in the lab, I mean, I know that you kind of actually, I want to go back to about the sleep trackers that you had talked about. You touched on actigraphy, and Darsh's got his Whoop on. I have an Aura Ring. I'm a fan of that just because of its low profile. But what are your thoughts on sleep trackers in general in terms of their accuracy? And obviously, we know the gold standard is, getting into a lab and polysomnography.
Right.
But just sleep trackers in general, what are your thoughts?
Well, they're certainly useful. They are making people much more aware of their sleep across our society than we probably were before they came about. I think I have a Whoop too, and I have a hard time just wearing things on my wrist. So like every time I tried with a Fitbit. I've got about like a 3-month shelf life for these things, and then they sort of make their way off my wrist. So maybe I should try the Aura Ring. Maybe the finger is a little easier to deal with. In general, I think they are great. They're great sort of everyday clinical tools, and they make doing research a good bit easier. We have sort of quote unquote research grade actigraph devices that are probably not all that much better than the commercial devices that you can get now. So I think the commercial space is really catching up and producing pretty high quality devices. I think the thing to look out for clinically, I guess as a psychologist, this is where I go. Some folks will become so overly reliant on what their kind of sleep score is looking like day to day that they might infer more into individual data points than maybe would be necessary. So that would be the thing I would look out for clinically. For example, some of these devices will provide sleep staging with and they'll claim very high degrees of accuracy on their website, and then it's kind of hard to figure out whether how truly accurate relative to, for example, a lab PSG these devices are actually becoming. But assuming that there is some degree of accuracy, you can have patients who might get really freaked out because they're noticing that their slow wave sleep is less on a few nights out of the week, and then that might drive their behavior in a certain way. And so I would be a little bit worried about putting too much credence in individual data points, but I think the ability to track, I think that is balanced and then some by the ability for folks to really get insights into their sleep habits and things like doesn't the Whoop kind of tell you if you've had something to drink a little too late
exactly.
at night? It'll remind you not to
there's
do
like
that.
a journal in the Whoop, and you can put, I wore blue blockers, or I drank some alcohol, or I slept in the same bed, or I had stress, and then it'll even break it down to how much earlier, do you need to do those activities to either show a positive effect or a negative effect on your sleep. Yeah. But I did have a question about that. So with these sleep trackers, having these journals, a lot of people are resorting to, breath work, meditation, things that might show a positive benefit on their sleep. Is there anything? So I think we know that during sleep, it starts to solidify those patterns that we have during the day, especially through learning and things like that. So when it comes to pain, is there anything that you really recommend that, people can do to kind of decrease their pain? Because when they go through sleep, it's going to kind of form that neural circuit to decrease their pain.
Yeah. Well, I think that's a good question. So the first thing to try to figure out is there a sleep problem on board, and then you can try to approach whatever the problem is through the variety of behavioral. I would go behavioral first, and then potentially cognitive if a person is in a position to work with a cognitive behavioral therapist. And we can. I'm happy to talk about those strategies if you would like. I think, for somebody who's in pain, who doesn't necessarily have sleep problems, I'm not aware of any kind of particular practice, sleep-related practice, if there's not a set of problems on board that one might engage in to try to have less pain the next day. I think the scientific literature anyway doesn't have that kind of level of granularity. But the things that we look out for in people who do have sleep problems are one of the key areas is what we call stimulus control, and that is we don't want to associate the bed with really anything but good sleep. Like if you're having sleep problems, you want the bed to be like your safe haven. Like when you see it, it should sort of trigger comforting thoughts and thoughts of I'm about ready to crash. And what happens very commonly is that people who develop insomnia and related sleep problems will start to kind of associate the bed with tossing and turning all night. And that's when if we're working with somebody clinically, we'll help them kind of develop a system for recognizing when they've been tossing and turning for a certain period of time, and then really systematically and rigorously sort of sticking to the plan of getting out of bed and not having that period of hyperarousal be associated with the bed. And if you can stick to that, it's sort of part of the constellation of techniques that typically result in it's going to get a little bit worse before it gets better. But if you can get through those periods of a few nights where you're kind of like awake and staying awake on the couch and out of the bed and going through that process, eventually you can kind of retrain your brain to associate your bed with good sleep and only be in there when you're like truly ready to go to sleep.
Now, Patrick, so I think that we can all agree. I'm definitely interested in learning some of the techniques that one might use in CBTI, but obviously sleep hygiene is probably first line treatment. Like we would talk about, again, wind down routine, making sure that the lights are all you're in a dark room. It's a cool room. I think those are things that people have probably heard about, but what are some other CBTI strategies that one might employ to address, either any type of insomnia that somebody might experience?
Yeah, no, you're right. Yeah, you want to like take care of the low hanging fruit, and the sleep hygiene stuff is generally that. It's important, I think, to distinguish sleep hygiene from CBTI, right? So sleep hygiene are aspects of sleep hygiene are a part of CBTI. A sleep hygiene intervention alone is not a CBTI intervention. And I think so you got it right exactly the way you explained it. I think a lot of providers may not appreciate that distinction and might think that sort of recommending sleep hygiene might be sufficient for somebody with an insomnia problem to start to get a hold of their sleep. And generally, a sleep hygiene standalone intervention is going to fail to achieve those goals. If that's kind of all that happens, it can work for people with generally with like subclinical issues, and might fix, as I said, some low hanging fruit. But people with like severe primary insomnia, that's not going to cut it. And that's where we get into the sort of set of techniques that are commonly involved in CBTI, and so those will include stimulus control, as I mentioned, where you sort of habitually force yourself to go somewhere else other than your bed when you're not able to sleep. there's also a sort of systematic process of sleep restriction that's a component of the CBTI therapy, and that's again a kind of systematic restriction of sleep and scaling back to your normal, sort of gradually scaling back to your desired level of sleep when you achieve certain benchmarks of sleep efficiency. And the whole point of sleep restriction is really to kind of generate that drive to sleep. Again, you kind of present it to patients as it's going to get worse before it gets better. And so patients really have to be on board with the idea that really kind of properly engaging in in CBTI is going to, for a week or two, result in feeling completely unrested because you're literally restricting your sleep like multiple nights in a row. But it can have profound effects, and that's just the behavioral component. That's what I find actually so fascinating about CBTI is really, with a lot of folks, just that behavioral component can really dramatically improve their sleep by physiologically driving folks to the point where they kind of are able to reset their system. And so you kind of scale back gradually until you achieve sleep efficiency benchmarks. One of the key techniques is you typically will pick a wake time that is kind of your ideal wake time. One thing the folks with insomnia often do is, they'll have a few nights of bad sleep, and then they'll have a night where they're actually able to sleep, and then they'll sleep through until like 10 a.m. to be able to recover that lost sleep. That might feel good on that morning where you sleep until 10 a.m., but it's like completely feeding into the cycle of insomnia. And so what we do in CBTI is you typically will choose a wake time that's like your desired wake time, and then you restrict sleep up toward that, and then scale back the bedtime. So if your desired wake time is 7 a.m., you might restrict sleep. You might make it so that your sleep time on the first night is 2 a.m., and then you kind of walk it back, 1:45, 1:30, and you walk it back till you get to eventually your desired point of whether it's 8 hours of sleep or 7 hours of sleep, whatever it might work for that individual. Those are the behavioral parts.
Patrick, that sounds like I find this to be fascinating because it's a pretty counterintuitive approach, right? If somebody has insomnia and they come to you and they're like, oh, well, I'm not sleeping well, I don't get enough sleep. And you tell them, okay, well, we're going to cut your sleep down. And they're like, well, that doesn't make any sense. I should be going to bed earlier, or I should be waking up later. So I imagine that's got to be a last line part of CBTI, right? Because it sounds like a miserable experience depending on how long you do it for.
No, it's actually like the first line. Yeah. That's where you go, right, to start. In fact, the cognitive stuff will typically come later, and in some folks, you might not even need to do it. The cognitive work is based on the premise that a lot of folks with insomnia have this kind of hyper arousal around bedtime. So leading up to bed, they'll develop a state of arousal that's greater than what they were in kind of during the day. And it's kind of like this approach to bed that all of a sudden starts generating arousal. And that tends to be associated with ruminative thoughts, anxiety related thoughts. And the cognitive component of CBTI can work with folks on kind of negotiating that type of thought pattern in and around bedtime. But yeah, I think a lot of practitioners will go with the behavioral work first, and it's a bit of a tough sell. Some patients, are going to tell you right off the bat that they're not into that. But if you can get buy-in from patients, it is a really a remarkable treatment because there's basically no side effects, certainly no long-term side effects, and it has as good as, and generally, and there are certainly a few studies that suggest better efficacy than any of the pharmacotherapies that are out there to treat sleep. So it is a frontline recommended treatment for that reason. And it's really one of the only, if you look across all of the other, most of the other sort of complex disorders that have a prominent kind of behavioral component to them, a CBT-like intervention is generally going to be considered like an adjunct. Like even with pain, even though pain, CBT, you could argue for a lot of folks that a CBT-based intervention should be a frontline intervention, but you rarely hear it talked about in pain circles in that way. It's typically considered a kind of a complementary approach or something that should be worked into a multidisciplinary approach to treating pain. With CBTI, it is a recommended front.
Yeah, I just want to say my father actually probably had insomnia for about a year and a half now. For the last 2 months, he exactly went through everything you just said, where the psychologist was tightening his window from probably like 11:30, 12 a.m. to about 5 a.m. and then slowly walking it back, like you said. And then the whole hyper arousal, wherever he was waking up, he would either do meditation, breath work, or get out of the room and come back in. And a lot of it he realized was, he was scared for his life, thinking, I can't fall asleep for a year now. He started to realize that this was just a lot of anxiety kind of in his head building up. And, finally he's got back into his routine. But you did mention ideal wake time and ideal bedtime. Is there a way that people can find out those two times?
Well, you usually pick the wake time based on your circumstances, right? So if you're somebody who has an infant in the house who's waking up every morning at 5:30 in the morning, you wouldn't choose, a wake time that's at like 7 a.m. That's just not going to serve you all that well. So typically you kind of, and similarly, work schedules and all kinds of other things are going to dictate people's wake time. So, often that's kind of, you got to work it around the practical realities of life. And then, the bedtime should be, that gets into maybe a more interesting discussion of like, so if you're picking if your wake time is more or less picked for you on most cases by the environmental circumstances that you find yourself in, how do you decide what your bedtime should be? How do you know whether you're somebody who is like perfectly cool sustaining on 6 hours of sleep versus somebody who really needs 8 hours? Some people might need 9 hours, right? And that's a trickier thing to figure out, particularly when you're in the throes of insomnia. And I would argue that probably the best way to go about that is to get yourself to the point where you're able to sort of consistently achieve a continuous night of sleep, night in and night out, and then really be tracking your sleep continuity in diaries or actigraphy, and then be completing self-report measures during the day to get a sense of your level of sleepiness, right? So you want to kind of correlate how much sleep you're getting at night with how sleepy you're feeling during the day. And if you're somebody who's consistently getting 7 hours of sleep a night, and all of your buddies are operating perfectly fine with 5 hours of sleep, and you're like, why do I feel like taking a nap all day? I'm getting 7 hours of sleep. Maybe that's because you're somebody who really needs 8 hours of sleep, and you should be titrating up.
Yeah, you're talking to a bunch of residents, and that's the irony of the situation.
Right.
Patrick, so what you're talking essentially about when you're talking about timing is the concept of chronotypes, right? And I think most people are familiar with night owls or morning larks. Circling back to the idea of when individuals come to your lab and you're looking at sleep's effects on pain, and you're doing these sleep deprivation studies, do you allow individuals to kind of just sleep whenever they want to sleep and wake up whenever they want to wake, or because again, that idea of somebody who's just natural chronotype might be they like to go to bed. I remember my medical school roommate would like to go to bed at 2, 3 in the morning and then wake up like 10, whereas I was the exact opposite. So how do you do that? I mean, how do you decide which hours they're going to sleep in when you're doing these sleep deprivation studies?
When we're doing the sleep deprivation, so that's a good question. Typically, we rule people out who have kind of major circadian rhythm sleep disorders. That being said, what you're describing probably isn't like a circadian rhythm disorder. Somebody like your roommate could have ruled into one of our studies, and we've got to sort of control for that in our analyses. So part of it is just kind of like a practical thing. It's very difficult to perform these types of experiments across people. They need to be standardized, and just like the timing of everything, we typically go for a standard bedtime and a standard wake time, and then we'll control for in our statistical analyses for variation in chronotype. So we pretty much always measure chronotype, and we'll get a sense of who's a lark and who's now. But if we could conduct the perfect experiment, then we would probably shift every night depending on somebody's habitual sleep times, and then start the experiment at that time. We haven't been able to do that just because of practical reasons, but that would probably be the best way to conduct it.
Yeah. So just again, going back to that idea of, sleep and pain, you mentioned some epidemiological studies and just talking about the association for individuals who already have insomnia and then their perception of pain. What about maybe not necessarily healthy individuals, but individuals with healthy sleep, and then you deprive them of sleep? Is that where the information about, hey, they're more susceptible to have a new incidence of pain, is that where that comes from?
A lot of those studies, really most of them, yes. We are attempting to conduct one of the first studies right now to do sleep deprivation in patients with chronic low back pain, as you know.
Yeah.
But the majority of studies are with healthy subjects, and we look at experimental pain sensitivity.
Yeah. Is there a specific, are you just, again, curtailing the total sleep time and you're kind of going for that quantity, or are there certain stages of sleep that will affect?
So you can, there are a number of ways to do these types of things. Our studies, we've typically employed a method that is called sleep continuity disruption, in which we essentially have 8 forced awakenings over an 8-hour sleep period. So we wake people up each hour at a sort of randomly determined interval and keep them awake for a portion of the hour, and then allow them to go back to sleep and then wake them up again. So it's this kind of repeated awakenings model. It's a pretty it's kind of like a blunt hammer to the notion of sleep maintenance insomnia. People with actual sleep maintenance insomnia rarely have that many awakenings or find themselves disrupted that severely, but it gives us a sense of really kind of the acute effects of something like that. And there's other ways to do it too. A lot of studies do total sleep deprivation, where you'll see, for example, 36 hours of total sleep deprivation or more in some cases. You will see sleep restriction, where you'll just scale back the sleep time, and you might allow people only a 4-hour sleep opportunity period, but that sleep opportunity period is a continuous one. And then there are more complicated designs where you can be tracking people's sleep stage in real time and wake them up when they enter a certain sleep stage. That's a really tricky type of study to perform, but it has been done. And then there are some kind of more elegant pharmaco disruption designs where there are certain pharmaceuticals. I believe, I believe it's clonidine. All right, I'm going to have to pull this study and give it to you. There are certain pharmaceuticals that can, for example, wipe out like REM sleep without disrupting total sleep time. So you can achieve a full 8 hours of sleep, but not get any REM, and really reliably expect that effect with the drug on board. And that's kind of a really nice and elegant way to just kind of wipe out one stage of sleep and sort of mechanistically test questions that you might have.
Yeah, I'd love to see that paper, because I mean, clonidine is a pretty common medication that we use for hypertension and a couple other things, even for in states of pain, actually. CRPS, we sometimes use that for that. Yeah, that would be cool.
It's probably not clonidine.
Well, I mean, either way, it's whatever it is. That's a drug that I'm trying to avoid for sure.
Well, Patrick, this has been everything you've been talking about has been super fascinating, especially your research, just for lack of a better word, awesome to me. In this field of pain, sleep, mental health that we're looking at, what is the direction of this field? Where is it going? Is there anything on the cusp that we're looking at? Anything on the horizon?
Yeah, lots of things. So we are, I can tell you about the studies that we're interested in. We're really interested in the effects of sleep on, as I mentioned earlier, these kind of reward-related processes and their implications for pain. And one of the, and we're interested in kind of two key areas with that. One is, do we see that sleep problems alter motivation, the ability to engage in naturally rewarding activities? And if we can demonstrate this, and we're starting to, if we can repeatedly demonstrate this and bring it into the context of pain self-management, I think that that's an area that's ripe for building novel treatments. And why in that particular way, we have these really great pain self-management interventions. CBT for pain is intended to help give people the tools to manage their pain on a day-to-day basis, for example. And there are, various meditation practices that can be really effective. One of the key components of really all of those interventions, but particularly the CBT related pain interventions, requires motivation to stick to the plan, right? So when you're asking a patient to engage in, mild exercise on a consistent basis, you've got to have the motivation to get up and do that and to overcome whatever obstacles might be in the way. And so we're really interested in seeing if sleep problems make it harder for people to effectively engage in those types of therapies. And if we can incorporate either interventions on the sleep side or interventions on the affect and reward side in folks who have sleep problems, we're hoping to sort of break that cycle and be able to help people more effectively engage in their own management of their pain. The other area that we're excited about generally in the sleep, reward, and pain space is in the context of opioids. So in patients with chronic pain who are prescribed chronic opioid therapy, and then also patients with opioid use disorder who have comorbid chronic pain and comorbid sleep disorders. With regard to that group of folks with OUD, there are very few treatments available that can help them manage that kind of constellation of symptoms while also managing the risk of relapse. And we know that pain and sleep problems will contribute to the likelihood of relapse in patients with OUD. So that's something that is really commonly reported by patients and that we see clinically, and there are some research findings starting to come together looking at that. So we think that treating sleep in patients with OUD might be able to help them manage not only some of the behaviors associated with addiction, but also might help them manage pain and manage their emotions on a day-to-day level that ultimately can result in better outcomes.
Well, Patrick, as we approach all of our bedtimes, we've been talking about sleep for the last 45 minutes or so. I think it's only right that we don't miss out on any of our sleep tonight. But before we let you go, how do people find you? How can people find your work if they're interested in it?
Good question. Well, I'm on the Hopkins Department of Psychiatry website. I've got a Twitter handle. I'm not super active on it, but getting more active at @P_Phi.
Love it.
Yeah. And we have, I would say, look me up on the Hopkins Psychiatry website and you can find a link to my stuff.
Love that. And we can throw that in the show notes for sure. Well, Patrick, I want to thank you so much for your time, being so generous and definitely dealing with our technical difficulties here. I think this has been a great primer in, these complex topics of both chronic pain and sleep. We know that sleep is kind of the bedrock, for when we're talking about the foundation of just good health. And, we've spent a lot of time talking about nutrition and exercise and just coaching in general. And this is one of our very first discussions of sleep, but I suspect it won't be our last. So thank you so much for your time.
Awesome.
Appreciate it. Thank you.
Thanks for having me on. All right.
All right, well, that was an awesome show with Dr. Patrick Finan. But before we end, don't forget to reach out to Larry Keller of Physician Financial Services for your disability insurance needs. He's been around for a while in many physician communities, helping them with the coverage they need. Find Larry at drpodcastnetwork.com/Larry Keller. All right, guys, time for that quick disclaimer. Everything in this podcast is for educational purposes only. It does not constitute the practice of medicine, and we are not providing medical advice. No physician-patient relationship is formed, and anything discussed in this podcast does not represent the views of our employers. We recommend that you seek the guidance of your personal physician regarding any specific health-related issues. And again, as always, if you really enjoyed this podcast or you like the other episodes, please rate, review, subscribe, and share, and spread the love. Until next time.